Okay, basically exactly the same as the gears are a couple other things. One's called a sprocket and chain, or sprockets and chain, and the other one's called a belt and pulley system. There is no difference between these and gears. We might use a sprocket and chain or a belt and pulley so that we don't have to use a whole bunch of idler gears and have some friction in between there. When we need two gears or pulleys like far apart. So in this one here, we're going to assume this is a sprocket and chain, which means technically there's like teeth around the edge, even though it's not really drawn that way. And then this is a chain that goes up over the teeth. One reason to use a sprocket and chain system is because there's like no slippage. You don't lose any slippage at all in that. However, it is noisier and a little rougher, and so you can lose a little bit of energy that way. But this is exactly the same, really, as two gears that were right next to each other meshed. This is a way we can just spread them farther apart, and we just wrap a chain around it, and it acts exactly the same way. So if you're trying to find the gear ratio, I guess in this one here, we're assuming the in. Right here, the red one is the drive, and then the blue one is the driven. So the thing with these, though, with the sprocket and chain, is like if this red one is rotating clockwise, then the driven one, the blue one, is actually also rotating clockwise. So normally you'd have to put a idler, like a single idler gear in between the two gears to get them to go the same way, or you could separate them and put a chain around both of these gears. And these gears, in this kind of system, these gears are just, the other word for these gears are called sprockets. That's all it is. So you take two gears, which now we're going to call sprockets, and we'll put a chain that hooks around them. So if this is the input, then you can do all these different ratios again. Remember, it's output over the input. So I could put the diameter of the output over the diameter of the input, and that of course would be 3 over 1.5, which means we have a gear ratio. This is gear ratio, sorry. It's still gear ratio even though it's a sprocket chain. So it would be of 2. Or I could look at the torques. The torque out over the torque in. Torque out is, 120 feet-pounds over 60 feet-pounds. Well, that's 2 over 1. That's another gear ratio of 2. I could also do, I could do number of teeth. Now, on this one, I guess I don't know what they are because we didn't really draw the teeth in. But I do know that blue wheel, that blue gear has, let's just say that it has 60 teeth. I know that input one would have actually 30 teeth because I'm still going to get the gear ratio of 2 to 1. Now, what's the backwards equation? Remember, all of these are outs over ins, but there's another one. Angular velocity is in over out. And what is the rotational velocity of the red pulley? It's 90 RPM. And the angular velocity of the out pulley is 45 RPM, and that's still 2 to 1. So whenever you look at a system like this, the small gear is going to have, big angular velocity. It's going to be rotating a lot of times for the amount of time that the blue one goes around. But the blue one is going to have high torque. And remember, gears and these sprocket and chain and belt pulleys, it's a trade-off between angular velocity and torque. Angular velocity and torque. In simple machines, remember, work was force times distance, and work is energy. So energy is force times distance. And so you had a trade-off between these two. A force, you could use a really large force on a small distance, or you could use a really large distance and a small force. Well, now what we're dealing with is what we call power. And power equals torque times angular velocity. And so it's kind of the same thing, but this time it's a trade-off between how much torque we have and how much angular velocity we have. So the big one is always going to be big torque, and the small one's always going to be big angular velocity. So we have a 2 to 1 gear ratio, which means if this is my driver and this is my driven, I'm going to increase the torque twice as much because I'm going to a bigger one. But I'm going to decrease the angular velocity by half. This angular velocity here will be twice as fast as what this one is. So that's sprocket and chain. There's like no difference between gears really. And then of course the other one is really the similar thing. It's a belt. These could be pulleys, and this is a belt. This is pretty smooth. It runs pretty well. But you could have a little bit of slippage with this, so there's kind of trade-off for both of these things. But again, the red one's going to look like it's in, so there's no teeth equation on this because these are pulleys. They don't actually have teeth, so we wouldn't be using that. We could still use diameter out over diameter in. This is gear ratios. Diameter out over diameter in would be, 6 over 2. So my gear ratio is going to be 3. I could also do torque out over torque in. Torque out is 55 over torque in is 18.33, right? That still would be a gear ratio of 3. And then I could do the reverse one. I could do the angular velocity in over the angular velocity out, and that would be 30 RPM over 10 RPM. It's still 3. Okay, so if this is our driver and this is our driven, we are going to be increasing our torque 3 times. That's what we're doing in this situation. We're increasing our torque 3 times. If this was our driver, and this was our driven, we would be increasing our angular velocity by 3 times. If we were going this way, we'd be increasing our angular velocity by 3 times. We would be lessening our torque by 1/3. But in this case, this is our driver and this is our driven, so we're increasing our torque by 3, and we're going to be rotating 1/3 as much. Instead of 30 RPM, we're going to only be rotating 10 RPM. So that's a pulley and a belt system. And pulley and belts, sprockets and chain, and gears are all the same thing. They're all exactly the same thing, except for gears. If you have 2 gears meshed together, they're going to spin opposite. And with the pulley and belt and the sprocket and chain, they'll actually be spinning the same direction.